In my hometown of Dinajpur and across much of Bangladesh, energy isn't just a utility, it is a daily uncertainty. I grew up with the hum of backup generators and the sudden silence of load shedding. But for me, the most frightening realization was the lack of power. It was lack of safety. Every year, hundreds of lives in my country are lost due to gas leaks and preventable energy accidents. As a child, I felt helpless. But as I grew older, I realized that these weren't just accidents, these were engineering failures. They were failures of control. This reality planted a seed in me. I didn't just want to generate energy, I wanted to tame it. I wanted to make it safe, intelligent, and accessible. That drive led me to WET, where I pursued mechatronics engineering. I pushed myself in the absolute limit, ranking first class first in my department with a CGPA of 3.88. But it was in the labs, not in the lecture halls, where I found my directions. Two specific courses changed my life: power electronics and drives and control systems. These courses taught me that raw power is useless without precise modulation. I began to see the grid as wires, but as a giant robot that needs brain. I applied this immediately. To address the safety crisis saw growing up, I designed a smart diesel stove. It wasn't just a stove, it was a safety system that integrated MQ6 sensors and to detect gas leaks and automatically shut off the fuel supply. I also built a humanoid robot, teaching myself how to integrate complex sensors and actuators. These projects proved to me that I had the skills to build the hardware, but I realized that hardware alone can't solve our energy crisis. The future is software defined. And this realization pushed me towards artificial intelligence. As a research intern at Neurontree AI, I am currently working on explainable AI. I am learning how to make these black box decisions transparent. Why does this matter for energy? Because the renewable energy grids of the futures, like offshore wind farms, are too complex for humans to manage manually. I am currently collaborating on a review paper that uses digital twins technology for floating offshore wind turbines. We are exploring how the virtual replicas can predict failures before they happen. This is a gap I need to fill. I have the mechatronics background and I have the AI skills, but I lack the specialized knowledge in decentralized energy systems to bring them all together. This is why DENSYS 2.0 is the only logical step for me. I need to understand how to scale my small smart stove concept into a smart city. The DENSYS curriculum, specifically the tracks involving energy storage and intelligent grids, is exactly what I need. I'm not just looking for a degree, I'm looking for a blueprint to redesign my country's energy infrastructure. You ask me my motivation? Okay, so this is my motivation. Bangladesh aims to be developed by smart nation by 2041, but we cannot achieve that with a centralized fragile grid. We need a decentralized microgrid that allows rural villages to be self-sufficient and resilient. When I return to Bangladesh, I plan to work with the Sustainable and Renewable Energy Development Authority. My goal is to design community-based microgrids that use AI optimization I learned at DENSYS to balance solar and wind loads automatically. I want to solve the problem I grew up with honesty, technicality, and permanently. I want to build a Bangladesh where power is safe, reliable, and intelligent. Thank you for giving me a chance to tell my story.